Okay, good morning. I've attached solutions to the problems I set on Monday. Um, I've taken a bit of a risk because they were really quite tricky. So well done if you had a go. And if you found them hard, then you were doing them correct because they were. And so please don't be too anxious if you weren't able to complete them. But here is the very last one, which was the nastiest. I'm going to show you how I did it. So I rearranged it like this, because this is descending powers of x, isn't it? This is x to the power of 1, this is x to the power of a half. So that's the same pattern as the others. And then I replaced the square root of x with y. And that means that y squared, the square root of x squared, is just x. So this becomes y squared, and this becomes y, so you get a quadratic, which you could solve. So that means that your y values are what the square root of x is. So the square root of x is 3, the square root of x is 1, and if you want to know what x is, when you know the square root of x, you square it, not square root, so there's no plus or minus to worry about. Square 3, you get 9, square 1, you get 1. But someone else did it a different way and got exactly the same answers. So they squared both sides of the equation, which you can do, but you've got to remember, we talked about this the other week, you can't square this side by just saying it's x squared plus 9. Squaring the left-hand side of that equation means gridding it out. So you get this. And that's because those two things are being added. But because these two things are being multiplied, this is a coefficient, you can square this by just squaring the 4 and squaring the square root of x. And the square root of x squared is x. So you end up with that. You can then take away 16x, and there was no substitution involved in that method, so I didn't have to work out my y values and then change them to x values. So you could definitely argue that that way was quicker and simpler, so well done. But the fact that there were two methods that gave you perfectly valid answers, that's why I heart sums. Of course, one thing I don't think I've shown you yet is how a calculator can be used to solve quadratic equations. You know, we're used to either factorising or using the formula, and there's the completing the square method as well, which we don't often use. But at A level, it's perfectly okay to use the calculator, whereas at GCSE, those of you who had those calculators that did it, I always said it was only for checking, perfectly okay to use it straight off. So let's solve the quadratic equation that came up in one of the questions on Monday. So I'm going to go to equation mode, and I'm going to select polynomial, and degree is the highest power of x, so it's an x squared problem. And if you see, you get a little sort of template here, and you're just asked to fill in the a, b, and c. Don't be thrown off by the fact this is x and we've got y, it's the same thing. So a is 2, so I do 2xe. B is -1, I've got -1y there. And C is -1. I already know the solutions are going to be -1/2 and 1, but it's reassuring to know. And it's interesting that if it's not an exact answer, you'll get a rounded decimal in this box up here, but if you highlight it, it gives you the Surd value down here. Now that doesn't apply in this case, but when we get to some harder ones, then that will help us. So there you go. You can use your calculator to solve quadratic equations. Okay, so we'll move on from indices. Still in the first unit of the A-level syllabus. And the next thing we come to is surds. Now, of course, surds and indices are linked because a surd is a square root, which is to the power of a half. But we've done lots of surds at GCSE, and we've already done a bit of surd work with the A-level induction stuff. Can I at this point remind you about the induction pack? So you should have a copy of that, and sort of working your way through that, ticking your way through that is really important, and maybe going through it a couple of times, because second week back in September, let's hope we are all back in September, we'll be doing a little assessment on that, and certainly you would have to get a good amount of that right in order to be able to carry on with the course. Anyway, let's do some Surds work this week. So here's a simplify question, not a solve, just a simplify. So my answer is going to involve Surds. I'm not going to get, there's no missing values here. And I've got three Surds in this problem, haven't I? I've got the square root of 80, I've got the square root of 20, and the square root of 45. And so the first thing I'm going to do if I'm being asked to simplify is I'm going to try and write these in a simpler way. And the way we do that is to write them as a square root that I know multiplied by a square root that I don't know. And what I'm hoping is that if I'm being asked to simplify this, the square root that I don't know, I'm hoping it's going to be the same in each case. So I'm going to ask you to pause the video at this point and see if you can simplify those surds. And I'm hoping that we'll end up with the same number here. Pause and have a go. Okay, root 80 is one that's hard to spot actually, because that's not something that we perhaps automatically know, but yeah, it's 16 times 5. So the square root of 80 is the square root of 16 times the square root of 5, and I know the square root of 16, that's 4. 20 is root 4 times root 5, and I know the square root of 4, it's 2. And 45 is 9 times 5, so root 45 is root 9 times root 5, and I know the square root of 9. And remember how we say these? This is 4 root 5, this is 2 root 5, this is 3 root 5. Okay, so if we have a look at the question then, we've got 3 root 80, 3 lots of that, so that's 12 lots of root 5. We've got 2 lots of root 20, 2 lots of that, so that's going to be 4 root 5. Remember, we can deal with these as if it was just 4x, 2x and 3x. And we've got 5 lots of root 45, 5 lots of that, so that's 15 root 5. Put it all together and you get 23 root 5. 12 lots of root 5, take away 4 lots of root 5, plus 15 lots of root 5. Okay, so I've put another attachment with 4 extra questions based along those lines. Hopefully a little bit easier than the last work that I set. And I will share the answers on Monday. I trust you are still all well.